Knowledge Targeting Part 13 of 50. This hour is about a sound with no source. A pulse of radio energy strikes a human head, and the person hears a click that nobody standing beside them can hear. That is not folklore. It is a documented physical effect, published in 1961, and it sits at the center of one of the most misunderstood claims in the targeted individual community. We begin with the physics. That sentence comes from the United States Department of Defense in a 1998 report titled Bioeffects of Selected Non-Lethal Weapons. It is not a leak. It is not an anonymous forum post. It is a planning assessment written for military readers and later released for unclassified reading. Notice the grammar, though. It says the technology could be developed. Conditional future tense. That single word, could, is the hinge this entire hour turns on. Knowledge Targeting is a 50-part documentary series produced by TI One Voice, written by Stefan van der AA. Its method is simple and unglamorous. Take a claim, find the primary source, read it, and say plainly where the documentation stops. Section 1 covered the lived experience of organized stalking. Section 2, which we are inside now, covers the technology, and the technology is where careless writing has done this community the most damage. Part 12 was Directed Energy Weapons, the non-lethal arsenal, the broad survey of beams, acoustics, and millimeter wave systems. This hour narrows to one effect inside that arsenal, the only one with an unambiguous peer-reviewed foundation. Part 14 then goes further out into synthetic telepathy and the brain-machine interface. So think of these 3 hours as a funnel. The arsenal, then the single documented mechanism, then the claims that reach beyond it. Everything cited here lives on the platform at one.witisk.org. There you will find the evidence library, where declarants upload documents and logs, the knowledge base, several thousand referenced articles that this script was built from, and the community wall, where members compare notes. It is free to read, and the sources for this hour are cataloged there so you can check every claim against the original paperwork yourself. There is also TITV, the community's round-the-clock live stream, running at meet.witisk.org under public TITV. Episodes of Knowledge Targeting are broadcast there on rotation, alongside interviews and archive material. Every part also has a written companion article on the platform, carrying the full reference list, so if you would rather read the citations than hear them, the text version is waiting for you there, free and fully footnoted. How was this hour assembled? Retrieval augmented generation over the TI One Voice knowledge base. In plain terms, the chapter text is the spine, and a search index pulls matching passages from thousands of catalog documents to supplement it. That method has one obvious failure mode. Retrieval returns whatever looks similar, including material about other episodes entirely. So every retrieved passage was checked against the chapter before it earned a place here. 3 registers, kept apart in every sentence that follows. Demonstrated, a named study, a named author, a year, a journal. Filed, a patent, a contract, a research proposal, proof that somebody wrote something down, not proof that a device was ever built or fielded. Claimed, testimony and inference, which matters enormously as human evidence but is not a measurement. Merge those 3 and you get exactly this genre's characteristic failure and every critic's easiest rebuttal. A word to anyone watching who hears voices they did not ask for. This hour will draw a hard line between what physics has demonstrated and what has only been claimed. That line is not a verdict on you. Nobody in this series will tell you what is or is not happening in your life, and nobody here will diagnose you. What we will do is refuse to hand you false certainty. Here is the route. First, the Cold War radar sheds where the effect was noticed by accident. Then Alan Frey's controlled experiments and his 1962 paper. Then the mechanism itself, thermoelastic expansion, explained from first principles. Then the Pentagon report, read line by line. Then the three engineering gaps: power, precision, and complexity. Then the Walter Reed digit experiment. And finally the vocabulary that grew around it: voice-to-skull, V2K, and synthetic telepathy. So let us begin properly with the thing itself. The microwave auditory effect, also called the Fry effect after the physiologist who first characterized it. Both names describe the same documented phenomenon: the perception of sound produced when pulsed radiofrequency energy is absorbed by tissue in the head. No loudspeaker, no air pressure wave arriving at the eardrum from outside. The skull itself becomes briefly the source of the sound. Let me be blunt about what is settled. That pulsed microwaves can produce an in-head sound is not contested by the relevant scientific communities. Alan Fry documented it in 1961 and published in the Journal of Applied Physiology the following year. Foster and Finch confirmed the underlying mechanism in the journal Science in 1974, working at the Naval Medical Research Institute. This is ordinary, replicated, citable physics, not fringe. Now the report itself. Bioeffects of Selected Non-Lethal Weapons was compiled in 1998 for the American military's non-lethal weapons program, and later released for unclassified reading. Read it as what it is: an internal survey of the literature. Where it describes the auditory effect, it is declarative, citing published work. Where it describes speech into a chosen head, it turns conditional: could, might, maybe, possible. Grammar is evidence. So here is the honest table. Demonstrated: clicks, buzzes, and hisses produced in human volunteers under laboratory conditions, at known frequencies, with the sound pitch tracking the pulse repetition rate. Not demonstrated in the open literature: intelligible sentences delivered covertly, at street range, through building walls, into one named person continuously for months. Between those two columns lies most of what the Internet calls V2K. That distance is measurable, and we are about to measure it. Three gaps separate the laboratory result from the operational claim. Power. The energy needed rises steeply with distance, and published human exposure limits are low. Precision. Reaching one person in a crowd, through walls, is an antenna problem nobody has solved in public. Complexity. Encoding a click is trivial, encoding a parsable sentence is not. And note carefully, a gap in the published record is not itself proof of a hidden program. The story does not begin in a physiology laboratory. It begins with an inconvenient complaint from people who worked beside very powerful transmitters. Through the late 1940s and the 1950s, both superpowers built early warning radar networks to spot incoming bombers and later missiles. The distant early warning line across the Arctic. The Pine Tree Line. The Mid-Canada Line. Enormous antennas radiating power levels the civilian world simply never encountered. Some of the earliest accounts are older still. A knowledge base entry citing Wired's reporting on the so-called Voice of God weapon notes that personnel described hearing sounds near radar transponders during the Second World War. Nobody investigated. Then, through the 1950s, technicians on the northern lines reported the same thing. Faint clicking, buzzing, or hissing that seemed to come from inside their own skulls, with no external sound to explain it. These reports were easy to dismiss and largely were. A radar station is a loud, crowded place. Generators hum. Cooling fans roar. Cabinets of electronics whine with transformers and switching supplies. Tell a supervisor you are hearing clicks and you will be told it is stray equipment noise or tinnitus or the end of a long shift. The accounts were sporadic, anecdotal, and recorded in no systematic way at all. They might have stayed there, a footnote in occupational health files, a story swapped at veterans' reunions, had they not reached a physiologist named Alan H. Fry. Fry was trained in biology and physiology, with a standing interest in sensory systems and the boundary between the physical environment and human perception. He was not the sort of researcher who waves away an anomaly, particularly one reported independently by people with nothing to gain. So he did what a good experimentalist does. He designed a test. The logic was simple. If the clicks are real, and if pulsed radiofrequency energy causes them, then it must be possible to reproduce them under controlled conditions. If they are imaginary, a properly controlled experiment will show that too. That was the reasoning in 1961. The execution, as we are about to see, was anything but simple. Frey's design was, in hindsight, a model of rigor applied to an unconventional question. He did not simply stand volunteers beside a radar set and ask them what they heard. He built a controlled exposure system, one in which every property of the radio signal could be set deliberately and changed on command, and in which the subject had no reliable way of knowing when energy was being delivered at all. Everything else followed from that decision. The apparatus was ordinary laboratory hardware rather than anything exotic. A signal source, an amplifier, a radiating antenna, and a subject seated at a measured distance from it. What mattered was the control. Frey could specify the carrier frequency, the power arriving at the head, the width of each pulse, and how often those pulses repeated, then hold everything else steady while he changed one thing at a time. That is simply how experiments are supposed to work. For properties of the signal did the work. Carrier frequency set how deeply the energy traveled into tissue. Power density set how much of it actually arrived. Pulse width, measured in millionths of a second, set how abruptly that energy was deposited. And repetition rate set how many of those deposits landed each second. Each could be varied on its own. Each, it turned out, changed what the listener reported hearing. The volunteers were recruited locally, tested for normal hearing, and screened for any history of ear disease, because a pre-existing auditory disorder would have muddied every reading. Each sat at a measured distance from the antenna, with head position noted, since the geometry of skull to antenna turned out to matter a great deal. And none of them was told on any given trial whether the transmitter was live. That last point is the whole experiment. The reason for that blinding is worth stating plainly, because it is the difference between science and anecdote. The thing under investigation was a perception. A person who expects to hear something will sometimes hear it. So Frey randomized the trials. Some carried pulses, some carried nothing, and the subject could not tell which was which. Two rates then emerged: reports during real exposure and false reports during silence. Only the difference between them counted. Those two rates were not the same. Under a range of pulse conditions, subjects reported clicks, buzzes, and tapping far more often than during sham trials, and the reports tracked the onset and offset of the pulses with real temporal precision. The gap between the exposure rate and the baseline rate was the experimental signal, and it was statistically significant. Not overwhelming, not theatrical. Significant in the ordinary, unglamorous sense a statistician means. The descriptions were consistent and unromantic. Clicking, buzzing, tapping, a diffuse hiss. Subjects placed the sound at the back of the head, or simply inside it, rather than anywhere in the room, which is not how an ordinary airborne sound behaves. And the sensation arrived at the instant of the pulse with no perceptible delay. Now notice what is absent from that list. Nobody in 1961 reported hearing words. Then came the detail that separates a physical effect from a psychological one. When Frey changed the pulse shape, the perceived sound changed with it, predictably and repeatably. A short, fast-rising pulse produced a sharp click. A longer pulse, or a train of closely spaced pulses, produced a buzz or something closer to a tone. Suggestion does not do that. Expectation cannot track microsecond variations in a waveform the subject cannot see. Hold that result at exactly its size. What was demonstrated in 1961 is that pulsed radio energy can produce a click, a buzz, or a hiss that a person perceives inside the head, in a laboratory at a known distance, sitting still. It was not a demonstration of speech. It was not covert, not at long range, not through walls, and not aimed at anybody who had not volunteered to sit there. The parametric tuning was the first line of evidence that something physical was happening. The second was much harder to argue with. Frey's subject pool was not made up only of people with ordinary hearing. He included several individuals with profound hearing loss, people whose outer and middle ears could not carry airborne sound to the cochlea in the normal way. On the conventional model, they should have perceived nothing at all. Consider what ordinary hearing requires. Air pressure waves strike the eardrum. The eardrum moves 3 small bones. Those bones drive fluid inside the cochlea, and hair cells turn that motion into nerve impulses. If Frey's clicks were simply airborne sound produced somewhere in the room, that whole chain had to be intact for anyone to hear them. In his profoundly deaf subjects, the first links of that chain were not intact. Some of those subjects detected the pulses anyway. Their reports matched everybody else's. Clicks and buzzes from inside the head, locked to the pulses with the same dependence on pulse shape and rate. That single finding killed the obvious skeptical explanation in one stroke, the explanation that the transmitter was rattling metal objects or producing corona discharge, and that everyone was simply hearing ordinary noise through their ears in the ordinary way. If the energy was not arriving through the ear, it had to be arriving through the skull. That was the map Frey drew in 1962, and it reframed the whole question. The issue was no longer whether the effect was real, because the deaf subject data had settled that. The issue was by what physical route a burst of radio energy, which carries no sound of its own, reaches the inner ear. In 1962 he published, in the Journal of Applied Physiology, a mainstream peer-reviewed venue with no appetite for sensation. The title was deliberately flat: Human Auditory System Response to Modulated Electromagnetic Energy. No weapons, no mechanism, no speculation about the future. The paper gave the apparatus the parametric relationships in quantitative terms, and the deaf subject data, then concluded only that pulsed energy could produce hearing by a route bypassing the normal apparatus. The reception was neither dismissal nor embrace. It was investigation, which is what a serious paper actually attracts. Bioengineering groups and military bioeffects laboratories set out to repeat the work. The TI One Voice knowledge base, drawing on J.J. McMurtry's survey of that literature, records the eventual verdict: direct experience among microwave workers, plus well-replicated animal data, made this the most accepted of the low-power microwave effects. That verdict, note carefully, is about clicks and buzzes. The chain runs like this: 1961, the experiments. 1962, the paper. Through the 60s, scattered replications, some clean and some ambiguous. 1974, Foster and Finch confirm the thermoelastic mechanism in the journal Science. 1975, Guy and colleagues measure the pressure waves inside the head directly. 1978, James Lynn of Wayne State University publishes the standard textbook. Roughly a dozen years from curiosity to consensus. Every one of those links is publicly checkable. Replication was slow for 2 rather dull reasons. First, the equipment. Stable, precisely controllable pulse sources were not sitting in ordinary university laboratories. You needed a specialist facility. Second, the effect itself is faint. The perceived sounds are quiet, easily buried under ambient room noise, and sensitive to exactly how the head sits relative to the antenna. Move the chair and you lose the click. Ambiguous results usually turned out to be geometry. For about 12 years, the microwave auditory effect lived inside specialist literature. Bioengineering journals, military bioeffects panels, the occasional acoustics conference. It was not secret. Much of it sat in open, peer-reviewed journals that any university library carried. It was merely obscure, in the way a great deal of solid science is obscure to everyone outside the narrow field that produced it. A cochlear researcher might know it. Your doctor did not. Keep that sequencing in mind, but do not overwork it. Quiet science first and dramatic attention later is the reverse of most debunked claims. It is still not a license to assume that everything later attached to the effect is proven. A 1970s Defense Intelligence Agency review said sounds, and possibly even words, could be induced. The word possibly is doing enormous work in that sentence, and we will test it properly. So the honest position, standing at 1974, is this. The effect is real, published, replicated, and it does not run through the ear. What it does run through is the skull itself, and that is the next question. How does a burst of radio energy, which contains no sound at all, become a pressure wave in bone and fluid? For that we need thermoelastic expansion, unpacked one step at a time. So here is the mechanism, and it has a name, thermoelastic expansion. For steps, each of them ordinary physics, chained together to produce something that feels extraordinary. A pulse of radio energy is absorbed by tissue. The tissue warms by a vanishingly small amount, but warms fast. Fast heating makes a pressure wave. The pressure wave travels through bone to the inner ear. And the inner ear does what it always does. No microphone is needed. No implant. No exotic receiver anywhere on the listener's body. The skull itself is the final stage of the signal chain, and that is the single most important and most frequently misunderstood fact in this whole subject. Understand these 4 steps and you can tell immediately which claims about voice transmission are physically coherent and which are not. So let us walk them one at a time slowly. Step 1 is absorption. Microwaves occupy the band from roughly 300 MHz to 300 GHz, and they interact with living tissue in 2 main ways. They tug on water molecules, and they push dissolved ions around. At 2450 MHz, the frequency in the foundational experiments and in the 1998 Pentagon report, water dominates. That is the same physics that heats your dinner in a microwave oven. But the scale could hardly be more different. A kitchen oven pours hundreds of watts continuously for minutes and lifts tissue temperature by tens of degrees. The auditory effect delivers microseconds, not seconds, on the order of millijoules per square centimeter at the skin, attenuated further through scalp and skull. The resulting temperature rise is measured in millionths of a degree Celsius per pulse. It is not a burn. You cannot even feel it as warmth. Step 2 is where the phenomenon leaves ordinary heating behind. Warm a metal rod slowly over a flame and it expands quietly. Nothing audible happens. But deposit the same energy in a pulse whose rise time is shorter than the time the heated volume needs to expand, and the tissue is trapped. Pushes outward as a mechanical wave. Thermal energy in, pressure wave out. Lightning does exactly this to air, and we call the result thunder. Step 3. The pressure wave never touches the air. It travels through the solid and liquid media of the head soft tissue, then the temporal bone that houses the cochlea, then the fluid inside that spiral organ. This is bone conduction, the same pathway that lets you hear your own voice while speaking, and the same pathway a tuning fork uses when a clinician presses it against the mastoid bone behind your ear. The deaf subject result we covered earlier is exactly what this pathway predicts. Fry tested people whose eardrums and middle ear bones could not carry airborne sound, and some of them still perceived the pulses. Their cochleae were intact. Only the delivery route was broken. Give an intact cochlea a different route in through the bone, and it responds normally. The skull supplied that route. No implant, no receiver, no science fiction required. Step 4 is simply hearing. The wave displaces the basilar membrane. The membrane deflects tiny hair cell bundles. Ion channels open. The auditory nerve fires. The signal climbs to brainstem, midbrain, and auditory cortex. What arrives at the cortex is a pattern of nerve impulses essentially identical to the pattern an ordinary airborne sound of the same frequency and amplitude would have produced. The subject hears a sound because a sound is what the brain received. The brain has no way to distinguish the 2 pathways, and no evolutionary reason to have developed one. So the percept is real, A person hearing a microwave-induced click is not imagining it. But mark the register carefully. The knowledge base entry on radio wave sickness puts the boundary plainly, and we will keep returning to it throughout this episode. A documented mechanism, but a speculative application to the complex experiences people actually report. Notice what has not been invoked anywhere in that chain. Absorption of microwaves by water is textbook dielectric heating. Thermoelastic generation of sound by pulsed energy is standard in materials science and medical ultrasonics. It is the working principle of photoacoustic imaging, where laser pulses create ultrasound inside tissue for diagnosis. Bone conduction underpins bone-anchored hearing aids. And cochlear transduction is the best-studied sensory process in neuroscience. For ordinary sciences, one strange result. Fry had established two things: that the effect was real and how it behaved under changing pulse parameters. What he had not done was measure the pressure wave itself. Psychophysics tells you what a person reports. It does not tell you how many pascals arrived at the cochlea. Pinning that down took a second team in a different institution 12 years later. In 1974, that team published, and the argument changed character entirely. Kenneth R. Foster and Edward D. Finch, working at the Naval Medical Research Institute in Bethesda, Maryland, published in Science under the title Microwave Hearing. Evidence for thermoacoustic auditory stimulation by pulsed microwaves. Science is not a niche bioengineering journal. It is one of the 2 or 3 most demanding general journals in the world. The paper ran barely 3 pages in the journal's compact format, and its influence was wildly out of proportion to its length. Their approach was a deliberate inversion of phrase. Instead of asking humans what they heard, they built a physical stand-in. A container of water, chosen because its acoustic and dielectric properties resemble soft tissue, fitted with a hydrophone, an underwater microphone sensitive to minute pressure fluctuations. They irradiated that chamber with pulsed microwaves at frequencies and pulse parameters matched to Frey's human trials, and they measured the pressure directly. No subjects, no reports, instruments only. That distinction matters more than it may sound. A psychophysical experiment can always, in principle, be challenged on the grounds that human beings are suggestible, or that they guessed when the transmitter was live. A hydrophone is not suggestible. Water does not want to please the experimenter. By removing the human observer from the measurement entirely, Foster and Finch removed the last plausible objection to the reality of the underlying physical event. The results were unambiguous. Every microwave pulse produced a measurable pressure transient in the water. When the amplitude was scaled to reflect the acoustic properties of human head tissue and the known sensitivity of the human cochlea, it landed comfortably inside the range that would be heard. The chain of causation was now complete and quantified. Energy deposited, heat, pressure wave, cochlea, sound. Not a correlation anymore. A specified physical mechanism. Publication in Science carried a signal beyond the findings themselves. Its editorial standard requires broad interest and high methodological quality. Acceptance told the wider scientific community, not just the small bioelectromagnetic subfield, that microwave hearing was a legitimate physical phenomenon with a specified mechanism, not a curiosity awaiting its first replication. The paper has been cited hundreds of times in the half-century since. It remains the mechanistic backbone of the entire field. There is a practical test you can apply to any discussion of microwave hearing you encounter. Does it cite Foster and Finch, 1974? If it does not, the account is either uninformed or is quietly avoiding the paper that makes the hardest scientific case for the very phenomenon under discussion. It disqualifies careless debunkers just as surely as it disqualifies careless believers, and we will hold ourselves to that standard too. Now the honest caveats and the knowledge base records them. Reviewers of the thermoelastic model have flagged 2 persistent difficulties. Some reported cases of microwave hearing occurred at power levels below what the model predicts would generate a detectable acoustic signal. And the model does not fully account for how auditory response varies across radio frequencies, particularly where tissue absorption behaves very differently. A correct mechanism is not the same thing as a complete one. And here is the distance this chapter must walk honestly. Everything demonstrated so far, Fry in 1961, Foster and Finch in 1974, establishes clicks, buzzes, hisses, and knocks. Simple, nonverbal sounds in a laboratory at measured distances with the subject positioned and consenting. Intelligible sentences delivered covertly through a wall to one chosen person at range is a different claim entirely. The published record does not reach it. Say clearly what that gap is and is not. It is a boundary in the published literature. It is not, by itself, evidence that something has been hidden. Absence of a published capability is not proof of a secret one, and treating it as proof is this genre's oldest mistake. So we go the other way into the numbers. Next, the equations themselves, which parameters actually govern the sound, and exactly what they permit. Foster and Finch had closed the loop by 1974. Pulsed energy in, pressure wave out, cochlea stimulated. What follows is the arithmetic underneath that sentence, and it matters more than it sounds because the equation names exactly which knobs an engineer would have to turn. A full derivation belongs in a textbook. The approximate relationship can be stated in a single line, and every quantity in it has been measured in real tissue. The acoustic pressure from a single pulse rises in proportion to 5 quantities. How strongly tissue absorbs at that frequency, how much energy the pulse deposits, how far the tissue expands when heated, and the square of the speed of sound in tissue. It falls in proportion to the tissue's specific heat capacity. Absorb more energy, expand faster, and the pressure wave grows. Loudness follows pressure. That is the whole relationship stated plainly. Take the terms one at a time. Alpha is the microwave absorption coefficient of tissue at the applied frequency. Phi is the absorbed energy fluence per pulse. Beta is the thermal expansion coefficient. V is the speed of sound in tissue, and Cp is the specific heat capacity at constant pressure. Not one of those is speculative. All of them are measured, tabulated, and published for biological tissue across the microwave range. The practical insight is narrow and useful. Perceived loudness depends linearly on the absorbed energy per pulse and on the absorption coefficient of the tissue. Both of those depend on frequency, which is why frequency choice is not a detail but a design decision. The knowledge base entry on Kenneth Foster puts the same point in plainer words. Loudness tracks the amplitude of the pressure wave, and that amplitude tracks the peak power of the pulse. 2450 MHz turns up again and again in this literature, and it is not arbitrary. At that frequency, the absorption coefficient of water-rich soft tissue is relatively high, so a useful fraction of incident energy becomes heat, and heat becomes pressure. It is a deliberate compromise between how deep the energy penetrates and how efficiently it is absorbed, chosen to maximize the acoustic signal reaching the inner ear. Push the frequency down and the energy travels deeper into the head but is absorbed less efficiently along the way. Push it up and absorption becomes superficial, dumping energy into the scalp rather than near the cochlea. The knowledge base places the effective band roughly between 200 MHz and 3 GHz, with peak sensitivity around 1 to 2 GHz. The foundational choice sits inside that window, for reasons the physics dictates. Total energy is only half the story. The thermoelastic effect requires stress confinement. Energy deposited faster than the heated volume can expand. For a millimeter scale region near the inner ear, that means pulse rise times of microseconds or less. Deliver the identical energy slowly, over milliseconds, and the condition fails. The pressure wave is far weaker and may be inaudible altogether. Same energy, a different shape, an entirely different perceptual outcome. That sensitivity to pulse shape is why the 1998 Pentagon report could call the phenomenon tunable and mean something physically precise. The report's own list of perceived sensations is short: buzzing, ticking, hissing, knocking. Notice what the list contains and what it does not. It is a palette of simple, nonverbal sounds, each traceable to a pattern of radio frequency pulses. It is a document describing effects, not a demonstration of a device. Think of the pulse train as a percussion instrument and the head as the resonator. Change the width of each burst and the spectral content of the click changes, the way a different mallet changes a drum's timbre. Change the repetition rate and the perceived pitch moves with it. Change the envelope and the texture shifts, from a steady hum to a warble or a knock. Simple, quantifiable inputs. Simple, predictable outputs. Why does a train of clicks become a tone? Because the auditory system hears closely spaced impulses as a continuous pitch at the repetition rate. That is repetition pitch, documented in the psychoacoustics literature since the middle of the last century, and entirely unrelated to microwaves. The basilar membrane decomposes any incoming vibration into its frequency components by mechanical action. Impulses arriving through bone meet the same machinery under the same rules. Tunability establishes a principle, not a capability. The phenomenon is graded rather than binary. Specific, quantifiable changes to the stimulus produce specific, predictable changes to the percept. But a technical review held in the knowledge base notes a limit. Because the stimulus reaching the two cochlea is generally incoherent, listeners localize the apparent source poorly. That matches what microwave hearing reports describe, and it is an obstacle any directional voice channel would have to overcome. That reframes the entire question. Not whether pulsed radio frequency can produce a sound in the head. And that is settled science. The open question is how much information can be encoded in a pulse train and reliably decoded by a listener's auditory system. Patents have been filed in this area, and a patent proves a filing, not a working device. A click is still not a sentence. Human reports were never the only line of evidence. Laboratory studies run in parallel showed that rats, cats, and chinchillas produce electrophysiological responses to pulsed microwave exposure consistent with auditory stimulation. Electrodes in the auditory brainstem and midbrain of anesthetized animals record evoked potentials time-locked to each microwave pulse, with latencies and amplitudes closely matching those produced by ordinary acoustic clicks. Different species, different laboratories, the same signature and conclusion. This matters for two reasons, and the first disposes of an early objection. Skeptics once suggested the human reports were products of suggestion or expectation. An anesthetized animal expects nothing, and brainstem-evoked potentials are generated far below the level of conscious perception or cognitive bias. If a microwave pulse reliably produces a brainstem response in a rat, the signal is entering the auditory pathway physically, not through the rat's imagination. The second reason is access. Animal work permitted invasive measurements that would be unethical or impractical in human subjects. Researchers placed electrodes directly on the round window of the cochlea and recorded the cochlear microphonic, the electrical signature of the hair cells, while varying the pulse parameters. Those recordings put transduction at the cochlea itself, not somewhere more central. The measured response was indistinguishable from that produced by equivalent airborne sound. Stand back and count the lines. Frey's Human Psychophysics in 1961. Foster and Finch's Physical Measurement in 1974, made with instruments and no human subjects at all. Then the Animal Electrophysiology that the knowledge base traces to work by A. W. Guy and colleagues by 1975. Three methods that can fail independently, converging on one statement. Pulsed microwave energy generates acoustic pressure inside the head, and that pressure stimulates the cochlea. Everything so far depends on bone conduction, and bone conduction is neither exotic nor contested. It is a standard clinical pathway. Every time a clinician sets a vibrating tuning fork against the mastoid bone to distinguish conductive from sensorineural hearing loss, the Rinne and Weber tests familiar to any medical student, they are exploiting it. An entire class of hearing devices, the bone-anchored aids, rests on exactly the same principle. You have experienced this yourself. Your recorded voice sounds wrong because, when you speak, vibration reaches your cochlea through the air and also through the bones of your own skull, which add low frequencies the microphone never captures. The cochlea sits encased in the temporal bone, among the densest in the body and an excellent conductor of vibration. Vibrate any part of the skull and the cochlear capsule receives it. This is why some of Frey's deaf subjects perceived the pulses. Their cochleae were intact. Only the airborne route, eardrum and middle ear bones, was broken. Provide another path and the organ responds. The knowledge base records two requirements from that early work: good bone conduction and residual hearing above 5 kHz. Scale Foster and Finch's measured pressures to skull bone and cochlear coupling, and they sit comfortably above the measured threshold. So the physics predicts an audible signal, and the psychophysics confirms one. That is a genuine, replicated finding. It is also a click, a buzz, a hiss or a knock. It is not an intelligible sentence delivered covertly to a chosen person through a wall. An absence of a published capability is not evidence of a hidden one. Next, the document that everybody quotes and that almost nobody has actually read. So the mechanism is settled. Pulsed microwaves heat tissue. The tissue expands. A pressure wave crosses the skull, and an intact cochlea hears it. That is physics, and it is not disputed. The question now is what the United States military itself wrote down about that physics in its own words for its own planners. In 1998, the Pentagon published a technical review called Bioeffects of Selected Non-Lethal Weapons. We are going to read it closely. That document did not appear from nowhere. The Cold War had ended, and American military planners were rewriting their assumptions. The organizing threat of 40 years, a vast conventional and nuclear confrontation, had receded. What planners now expected was smaller and messier. Peacekeeping, humanitarian intervention, counterinsurgency, urban operations where fighters and civilians stood in the same street. In that world, a weapon that could stop someone without killing them stopped being a curiosity and became a requirement. Through the early 1990s, a series of studies, workshops, and technology assessments surveyed almost any physical effect that might incapacitate or deter a human being without lasting harm. The list was eclectic and, read today, slightly absurd. Slippery foams, sticky nets, irritant chemicals, acoustic devices, dazzling lasers to disrupt vision, and, sitting quietly among them, directed electromagnetic energy. Microwave hearing entered the Pentagon's paperwork not as a secret program but as one item on a shopping list. The Joint Non-Lethal Weapons Program was formally established in 1996, with its directorate at Quantico, Virginia. The 1998 report was one product of that effort. A technical review compiled by military and civilian scientists, cataloging what the scientific literature said about several candidate technologies. Note the register carefully. This is a filed institutional document. It records what was written, reviewed, and believed inside a bureaucracy. It is not, by itself, evidence that anything was ever built. And yet, its institutional position makes it unusually trustworthy on its own terms. This was not a public-facing document written to persuade anyone. It was an internal assessment for technology program managers who would spot exaggeration immediately and who wanted to find effects that worked. Its authors had no reason to inflate the science and no reason to bury it. Read it as what it is, a sober summary of what one military establishment understood in 1998. The report is organized by technology area. Acoustic weapons, optical disruptors, chemical agents, directed electromagnetic energy. Microwave hearing occupies only a few pages of a much larger volume. Its weight comes not from length but from tone. Most sections of that report describe technologies that were, in 1998, speculative or barely past proof of concept. The microwave hearing pages describe something already studied since Alan Frey's discovery in 1961, and replicated for 3 decades since. So the confidence is uneven across the volume, and that unevenness is informative. By 1998, the mechanism of microwave hearing was understood, the frequency was specified, the perceived sounds were catalogued, and one speech transmission test had been conducted and referenced. That is a mature body of work. But the report does not call it a fieldable weapon. It hedges on range, on portability, on complexity. Settled physics and deployable hardware are 2 different claims. Here is the report's central sentence on the phenomenon, and the wording repays attention. Notice the verb. Humans experience these sounds. Not report, not claim, not allege. The authors are writing about an established perceptual fact, the way you would write that a bright light causes an afterimage. That single verb choice tells you where the microwave auditory effect sat in 1998, inside the American defense establishment's own understanding of settled science. Now look at what the sounds actually are. Buzzing, ticking, hissing, knocking. Those are elementary auditory percepts, each tied to a pattern of pulsing. They are not words. They are not sentences. They are not voices. And the location matters too. The sounds originate within the head, exactly as bone conduction predicts, because the pressure wave is born inside the skull and never becomes an airborne signal the ear could place outside. The report then names the number. Short pulses of radio frequency energy at 2450 MHz, it says, can generate a pressure wave in solids and liquids. 2.45 GHz is the same band your kitchen microwave oven uses, chosen in the laboratory because water-rich tissue absorbs it efficiently. And again, watch the verb. Can generate, not might, not may. A statement of demonstrated capability, published by the Department of Defense. Then comes tunability. The report states that the frequency of the sound perceived by the subject is a function of the pulse repetition rate. In plain terms, change how often the pulses arrive, and the pitch in the head changes with it. That is a specific testable relationship between a knob on a transmitter and a perception inside a skull, and it is the hinge on which the rest of this chapter turns. Because if simple pitch can be controlled by pulse timing, then in principle richer acoustic information could be encoded in a more elaborate pulse train. The report implies that without quite saying it. Decades later, a United States Air Force patent, number 6587729, claims apparatus for audibly communicating speech using the radio frequency hearing effect. Patent proves a filing. It does not prove a working device and never has. Which brings us to the single most quoted sentence in the entire document. It is not a statement about physics. It is not a description of a mechanism. It is the record of something that actually happened in a laboratory with a transmitter, an antenna, and a human volunteer. 10 words were sent. 10 words were heard. Everything that follows in this series about voice to skull leans, in the end, on this one experiment. Read it slowly because every clause is load-bearing. Communication of the words from 1 to 10. Not conversation. Using speech-modulated microwave energy. Not sound, not a speaker, not a bone conduction pad. Was successfully demonstrated. Past tense, declarative, no hedge. This is the sentence that launched 1,000 websites, and the remarkable thing is that, read exactly as written, it is almost certainly true. It is also the sentence most often quoted without its limits. The demonstration traces to work conducted at or in association with the Walter Reed Army Institute of Research in the early 1970s, roughly a decade after Fry and contemporaneous with Foster and Finch's 1974 confirmation in Science. Its most widely cited published account is not a research paper. It is a 1975 review article by Don Justison, titled Microwaves and Behavior, in the journal American Psychologist. The Pentagon report is citing that older literature. The experimental setup, reconstructed from the published literature, was simple. A researcher recorded a human voice speaking the isolated digits 1 through 10. The recording was processed to extract its amplitude envelope, the slowly varying contour of loudness that carries much of the information about which phonemes are being spoken. That envelope then modulated the pulse timing of a microwave carrier. An antenna radiated it toward a volunteer sitting perhaps a meter away, who reported what they heard. One honest caveat, and it matters. The digit experiment was never published as a primary research paper. It reaches us through Justison's review and through James Lynn's 1978 book, Microwave Auditory Effects and Applications. The knowledge base makes the same point. A Defense Intelligence Agency review of Soviet literature gets quoted just as often, but a review summarizes other people's claims. The most famous result in this field rests on a secondary record. The listeners heard the digits. Depending on the study, recognition ran from roughly 70 to 90%. Not perfect, but far above chance and far above anything guessing or cueing could explain. 10 single-syllable words, transmitted on a microwave carrier and correctly identified by a human ear that received no airborne sound at all. That is a genuine and remarkable scientific result, and it deserves to be stated without hedging, because it is true. And now the boundary stated firmly. It was not continuous speech. The digits were isolated, with pauses, none of the co-articulation or prosody of real sentences. It was not covert. The subjects were volunteers who knew what was being tested and were asked to report. It was not at range. The antenna was close enough that power density at the head far exceeded anything achievable at tactical distance. And it was not aimed at one person among many. 10 numerals correctly recognized, a meter from a laboratory antenna, with a consenting subject. Real, remarkable, and bounded. The claim that intelligible sentences are being delivered covertly into a chosen person's head, through walls at distance, is a different claim entirely, and it is testimony and inference, not demonstrated capability. That the record stops here is not evidence of a hidden program. Next, we read the report's hedges, where its own language turns conditional. 10 numerals correctly heard beside a laboratory antenna. That is what the 1998 report demonstrates. But its most instructive passages are not the declarative sentences at all. They are the hedges, the conditional lines about what might one day become possible. Those sentences sit in a different grammatical register from the flat statements of fact, and a careful reader has to hold the two apart. So let us read those hedges, slowly. On the question of range, the report says this. Communicating at longer distances would be possible with larger equipment, while shorter range signals could be generated with portable equipment. Read that slowly. It is a general engineering statement about the relationship between antenna size, transmitter power, and effective distance. It holds for every radio system ever built, from a broadcast tower to a handheld set. It is a truism, not a measurement of anything. An amateur radio operator could write exactly that sentence about the equipment in their garage. Bigger antenna, more power, further reach. Smaller box, shorter range. Nothing in the line claims that a working covert speech transmitter existed in 1998. Nothing in it gives a distance, a power level, or a piece of hardware. It states a physical fact that no engineer would dispute, and it should not be read as a disclosure. Then comes the larger leap, from 10 isolated digits to continuous, grammatically structured speech. And here the report's own grammar changes. It stops making statements and starts making projections. Listen to the tense. It seems possible. Could be developed. That is the future conditional, and it is doing exactly the work it appears to do. The authors describe a capability that physics does not forbid, not one they can point to. Set the two registers side by side and the shape of the document becomes obvious. On the left, flat declaratives about things already observed. The clicks, the mechanism, the 10-digit words, the carrier at 2450 MHz. On the right, conditionals about things that might follow. Would be possible. Seems possible. Could be developed. No date, no power figure, no hardware. That boundary runs straight through the report. This is the single most common point of conflation in popular arguments about microwave hearing, and it is made in both directions. Advocates of the maximal voice-to-skull claim quote the declarative sentences and apply them to the conditional ones. Skeptics quote the conditional sentences as though they cast doubt on the demonstrated physics beneath. Both readings destroy the same distinction. The report is far more useful and more interesting read exactly as written. There is something almost reassuring in those hedges. A document written to sell a capability does not say seems possible. It says will deliver. The conditional tense appears in this assessment precisely where its authors reached the edge of what they actually knew, and that is the mark of technical people writing honestly for a technical audience. The hedge is not a cover story. It is the visible shape of an admitted limit. One further line from the same report deserves its own extended treatment, because it is at once the most unsettling detail in this chapter and the most scientifically ordinary. Microphones placed beside a person perceiving the sound record nothing at all. In popular retellings that becomes proof of something sinister and undetectable. Read against the mechanism established earlier in this episode. It is not mysterious in the slightest. It is precisely what the physics predicts. Follow the energy. A microwave pulse travels through the air, is absorbed in soft tissue near the cochlea, and produces a rapid, very small thermal expansion. That expansion launches a pressure wave in the bone. The bone carries it to the inner ear, where it becomes a nerve impulse, and then a perceived sound. At no point in that chain does the signal exist as airborne sound in the room. There is nothing outside the head to capture. The privacy of it is eerie and mundane at the same time. Eerie because a voice audible to one person and silent to everyone else in the room feels like a breach of shared reality. Mundane because the same physics explains why your own voice sounds different to you than on a recording, and why a bone-anchored hearing aid delivers sound to its wearer alone. Strange to experience, entirely ordinary to explain. That microphone invisibility carries a sober methodological consequence, and it cuts in every direction. A percept leaving no ambient audio trace is extremely hard for anyone outside the listener to verify in real time. The knowledge base makes a parallel point about incident diaries. The widely circulated 1000-event memory log has no recognized evidentiary value in any court. Documentation of an experience is not documentation of its cause. That limit is real and it is not going away. But the reverse inference is not airtight either. The usual default runs. No external sound, therefore hallucination. That reasoning quietly assumes airborne sound is the only route to the cochlea, and 6 decades of published work say it is not. A real physical pathway exists that produces exactly this combination, a subjectively real percept with nothing measurable in the air. Knowing that confirms nobody's report. It reopens a question that was being closed too quickly. So hold the line carefully in both directions. The absence of a microphone signal cannot settle whether a perceptual report is true, and the absence of published capability cannot establish that a hidden capability exists. Nothing here is proof of suppression. A gap in the record is a gap, and treating it as a concealed achievement is the characteristic failure of this entire genre. The honest position is narrower than the loud one, and considerably stronger. We now have enough to build the central table of this chapter, the documented and the undocumented, laid side by side with no hedging in either direction. Begin with the left-hand column, the findings supported by published, peer-reviewed, publicly available evidence. This is the ground that holds weight. It deserves stating in full, because it is far more solid than most contested claims in this domain can offer, and it is routinely understated. The dates matter here. Phrase first reports, 1961 and 1962. The Walter Reed digit demonstration in the early 1970s. Foster and Finch's mechanistic confirmation in 1974. Justison's review in American Psychologist in 1975. The Pentagon assessment of 1998. And, as the knowledge base records, a synthesis published by Elder in 2003 that closed the remaining argument over mechanism. 6 decades, many laboratories, one convergent picture. Take the mechanism first. Thermoelastic expansion, in which absorbed radio energy becomes a mechanical pressure wave through very rapid heating, was confirmed by Foster and Finch in 1974 using physical instruments in a tissue-equivalent model, not human report. Later investigators added direct acoustic measurement, electrophysiological recording from the auditory brainstem and cochlea of animals, and computational modeling in anatomically realistic head models. This is not a hypothesis awaiting confirmation. Then the speech result stated exactly. One demonstration. 10 single-syllable digit words, carried by speech-modulated microwave energy, recognized well above chance in a controlled laboratory in the early 1970s. The knowledge base preserves a contemporary account describing the listening researcher recognizing words modulated onto a microwave carrier by an audiogram, an analog of their sound vibrations. Real, remarkable, precisely bounded, and in the open literature still the only one of its kind. Alongside the mechanism sits a set of smaller findings that have simply held. Simple percepts, clicks, buzzes, taps, hisses and knocking, reproduced across decades and across laboratories. The threshold energy required, and the way the percept tracks pulse repetition rate and pulse shape. The carrier frequency named in the Pentagon report. Localization inside the head. And phrase finding that some profoundly deaf subjects perceive the pulses, which rules out an ordinary airborne route. None of this rests on a single paper. James Lynn at Wayne State University wrote an entire book, Microwave Auditory Effects and Applications, examining the candidate mechanisms. The knowledge base summarizes the position plainly. The numerous microwave voice transmission citations rest on a considerable foundation of microwave hearing literature. Note that wording carefully. A foundation is what you build upon. It is not, by itself, the finished building that anyone claims is standing. So that is the left-hand column. 60-plus years of convergent, independent work across bioelectromagnetics, auditory physiology and engineering, and no published study has overturned any of it, which makes the next task unavoidable. We turn to the right-hand column, the claims routinely asserted about voice-to-skull for which no public, verifiable evidence exists, and we will state those with exactly the same plainness. The same standard, applied to the side of the ledger that flatters nobody. That is the left-hand column, and it is solid ground. Now turn the page over. The right-hand column holds the claims that travel everywhere in popular discussion of V2K and microwave hearing, and for which no publicly available, peer-reviewed, verifiable evidence exists. Naming them plainly matters as much as naming the documented findings, because a column left vague is a column that quietly borrows credibility from the one beside it. 4 claims sit in that right-hand column. Continuous, naturally flowing, intelligible speech. Covert delivery at meaningful range. Targeting of one specific person inside a crowd. And a fielded, operational covert speech weapon. Each of these is asserted routinely as though the published science already carried it. None of them is documented in the open, peer-reviewed literature. We will take them one at a time, and we will be specific about where each one runs out. Start with speech. No published, peer-reviewed study has ever demonstrated continuous conversational speech, full sentences, natural prosody, blended sounds, real meaning, carried through the microwave auditory channel. A Defense Intelligence Agency review of communist bloc literature, held in our knowledge base, went as far as this wording, sounds and possibly even words appearing to originate inside the head. Notice the hedge. That is a review of other people's papers, not a demonstration anyone performed and published. Set the two side by side. What was shown? 10 rehearsed single-syllable digit words, one talker, one listener, recognized above chance. What is claimed? Open-ended sentences in a recognizable voice, delivered to a chosen person at distance. The distance between those columns is not more of the same. It is a different order of demand on the channel's information capacity and on the fidelity of the modulation that rides on it. It is worth being precise about what that early result established. A listener, expecting words, drawn from a closed set of 10 he already knew, identified them at better than chance. That is a real finding and a genuinely surprising one. It is not evidence that a paragraph can be conveyed, or a conversation, or an extended monologue understood as natural speech. Recognizing one of 10 known options is a different task from understanding open language. Our knowledge base entry on the bioacoustics researchers Sommer and von Gierk states the mainstream position bluntly. Their point is not that the effect is fake. They accept the effect entirely. Their point is about what the effect can carry. Pulsed energy in specific frequency bands producing simple percepts is one thing. Complex speech signals are another. On that distinction, the published record has been consistent for half a century. The second claim is covert delivery at meaningful range. No publicly available study has shown the microwave auditory effect working against a person who did not know they were being exposed, at any distance beyond the immediate vicinity of a laboratory antenna. The documented demonstrations used consenting volunteers who had been told exactly what the experiment was, seated typically a meter or less from a radiating antenna, in a controlled room. Hold those two pictures together. A volunteer at 1 meter, briefed, still, facing a fixed antenna in a shielded room. And a stranger crossing a street at 100 meters, moving, unaware, with walls and vehicles and other bodies between them and any transmitter. Those are not the same experiment at different scales. They are different experiments, and only the first one has ever been run and published in the open literature. Third claim, singling out one person inside a crowd. No public study has demonstrated aiming this effect at one individual while excluding people standing beside them. Every documented experiment involved a single subject at a known position, in a known orientation, relative to a fixed antenna. Isolating a specific, possibly moving person in an uncontrolled space, without touching anyone adjacent, is a fundamentally harder beamforming problem, one the public literature never claimed to solve. The fourth claim is the maximal one. A finished device in service, covertly delivering continuous intelligible targeted speech at range. Patents do exist for in-head sound by radio frequency and by ultrasound. A patent proves that somebody filed a document and paid a fee. It does not prove a device was built, tested, or works. No publicly available evidence supports the fielded weapon. As of this writing, it is an allegation, not a demonstrated fact. Now the sentence that has to be said carefully in both directions. This does not prove no such device exists. Classified programs are, by definition, invisible to public scrutiny, and absence of public evidence is not evidence of absence. But absence of evidence is not evidence of presence either. Anyone asserting the maximal claim as established is either relying on material that is not public, and should say so, or going beyond what the record shows. So walk the engineering in plain terms. 3 gaps account for most of the distance: power, precision, and complexity. Take power first. Radio frequency energy spreading in 3 dimensions obeys the inverse square law. Double the distance and power density falls by a factor of 4. Triple it and it falls by a factor of 9. To hold the same intensity at the listener's cochlea, transmitter power has to climb the same curve upward. Put numbers on it. A laboratory demonstration at 1 meter needs a certain transmitter. The same power density at 10 meters needs roughly 100 times that. At 100 meters, through walls with atmospheric and structural absorption, you need a transmitter and antenna system far larger than anything a person carries. None of this is forbidden by physics. Radar and satellite uplinks handle far more power. But the popular V2K literature almost never states it quantitatively. One line from the 1998 Pentagon report gets quoted constantly. It says longer distances would be possible with larger equipment, while shorter range signals could be generated with portable equipment. Read against the experiments it cites. The short range in that sentence means the laboratory range, a meter or less. It is not describing a handheld unit that reaches someone across a street. It is a truism about antennas, true of every radio ever built. The precision gap comes next. The report specifies a carrier near 2450 MHz, which puts the wavelength at roughly 12 centimeters. That is small enough that a moderately sized phased array could achieve useful directivity. It is not small enough to focus on one human head, at tens or hundreds of meters, through walls and intervening structures, when you do not know precisely where that head is or which way it is facing. And a beam aimed at anyone in a real environment does not stop at them. It illuminates walls, windows, furniture, vehicles, and every other body nearby, producing reflections, scattering, and unintended exposure of bystanders. The published microwave hearing literature contains no analysis of any of that, for a simple reason: it was never written for covert operational use. Those papers were safety studies and physiology studies. Nobody was solving a targeting problem. Which brings us to the third gap: complexity. 10 rehearsed single-syllable words, spoken by one talker under studio conditions, carry a tiny amount of acoustic information. Each word's amplitude envelope is a slow, simple contour that a modest number of samples can describe. Painting that contour onto a microwave pulse train is a manageable signal processing job. That is the whole documented speech vocabulary of this field. 10 words. One talker. Ordinary conversation is a different animal. Speech sounds blend into their neighbors, co-articulation, so no phoneme is acoustically independent. Prosody carries syntax, emphasis, emotion, and speaker identity through pitch, timing, and loudness. Add tens of thousands of words, variable speaking rates, many talkers with different vocal tracks, and noisy rooms degrading the signal before anything is encoded. Carrying all of that through a pulse train needs modulation far beyond simple envelope encoding. None of the three gaps on its own proves the larger claim false. Classified programs exist precisely to bridge gaps like these, and the public record cannot rule out what it cannot see. What the gaps do establish is that the larger claim is not a simple extrapolation from the documented science. It is a different claim needing different evidence. Our sources for this chapter sit in the archive at one.witisk.org. So the honest position is a boundary, not a verdict. The physics is real. The mechanism is confirmed. One narrow speech demonstration happened. Beyond that line, the public evidence stops, and saying so is not a claim that nothing lies past it. Which raises the obvious next question, and the one worth asking carefully: what would actually count as proof? Naming that bar precisely and honestly is where we go next. Power, precision, complexity. Three gaps, none of them proof that the larger claim is false. So the honest next question is not whether the gaps can be argued away, but what would actually close them. It helps to ask concretely what evidence would settle the larger question. Naming the bar makes the present gap easier to see clearly, rather than to argue about endlessly. So let us name it plainly in three parts. A convincing demonstration of the maximal voice-to-skull claim would need three things at minimum: Continuous, naturally spoken sentences, recognized reliably, with accuracy measured and reported in a peer-reviewed journal. A named, tested working distance, stated in meters, and some independent physical confirmation that the exposure actually occurred. 3 requirements. Each one ordinary, unglamorous, and entirely standard in any other branch of experimental science. None of them is currently satisfied in the public record. The first requirement is the hardest. Not isolated digits. Not lists of single-syllable words. Real sentences with the full acoustic and linguistic complexity of ordinary conversation, perceived reliably by a listener, with recognition accuracy measured and reported, and published somewhere with genuine peer review. That is the difference between an anecdote and a finding. The words 1 to 10, correctly recognized at a meter, does not clear that bar. It was never meant to. Peer review is not infallible, and this series will not pretend it is. Reviewers miss things, journals publish errors, but it filters out fabrication, wishful thinking, and uncontrolled variables in a way that a forum post cannot. The knowledge base puts the same point flatly. The leap from laboratory demonstrations of simple auditory perceptions to the transmission of complex speech remains, in its words, scientifically unsubstantiated. That is a description of the literature, not a verdict on people. The second requirement is a number, not the general principle that bigger equipment reaches further, an actual working distance tested and measured. 3 meters, 30 meters, 300 meters. Whatever the figure is, it has to be stated so the claim can be checked against the physics of radio propagation and compared with other demonstrations. The laboratory work we have cited operated at roughly 1 meter. That is the only published range we have. Here is why the number matters so much. A claim with no specified range is a claim that cannot be tested and cannot be shown to be wrong. And a claim that cannot be shown to be wrong is not a scientific claim at all. It is an assertion wearing scientific clothing. That is not a criticism of anyone's experience. It is a statement about what the sentence, as written, can and cannot support. The third requirement is a physical trace. Instrumentation in the room recording the radio frequency signature. A calibrated power density measurement taken at the subject's location. Something beyond the listener's own verbal report. This is not an arbitrary demand invented to make the claim harder to prove. It follows directly from a property we established earlier in this episode. The perceived sound leaves no ambient acoustic trace whatsoever, because it never exists as airborne sound at all. That puts the listener's report in an awkward double position. The most essential evidence, because only the listener perceives the sound, and the most vulnerable, because expectation and suggestion can contaminate any subjective account. The knowledge base notes that personal incident logs, however diligently kept, carry no recognized evidentiary weight in court. A log records the report. Instrumentation would record the exposure. Those are two different things, and the second one is missing. Set the two side by side. On one side, the documented demonstration, 10 isolated digit words, a consenting volunteer, an antenna roughly a meter away, recognition well above chance. On the other, what would settle the larger question? Full sentences, a measured range, instrumented confirmation, genuine peer review. The knowledge base entry on bioelectromagnetics researcher Kenneth Foster puts the effect at the center of V2K claims. Centrality is not the same as sufficiency. None of those three elements currently exists in the public scientific record for the maximal V2K claim. That absence is worth stating without triumph and without despair. It is not proof that covert, long-range voice transmission is impossible. Classified capability remains a genuine unknown this chapter cannot rule out and does not attempt to rule out. It is simply an honest description of where the publicly verifiable evidence stops. Nothing more. So let us count. Not rhetorically, literally. There is one number at the center of this chapter, and it is a number many people on both sides of the argument would rather not look at directly, because 0 is unusually easy to overstate and unusually easy to hide. It deserves to be said out loud, precisely, with its qualifiers attached, and then examined rather than shouted. That is what this section does. The number of peer-reviewed, publicly available demonstrations of covert, long-range, continuous, naturally intelligible voice-to-skull speech is, as of this recording, 0. Every word in that sentence is doing work. Peer-reviewed, publicly available, covert, long-range, continuous, naturally intelligible. Strip any one of those qualifiers away and the count changes, because the narrow laboratory demonstration is real. Keep them all and the count is 0. 0 is a defensible number, and it belongs on the page. Be careful what 0 means. It does not mean zero evidence for the microwave auditory effect. We have spent this episode establishing the opposite. Fry in 1962, Foster and Finch in Science in 1974, Kane's work in the mid-70s, cataloged in the knowledge base. One narrow speech demonstration, all genuinely documented. The 0 applies to one specific, harder claim and to nothing else. A boundary in the evidence is not a verdict on anyone's life. Counting honestly runs in both directions. Anyone asserting the fully developed, weaponized version as established fact is going further than the public science supports. And anyone dismissing the whole subject because that version is unproven throws away 60 years of legitimate physics along with it. The knowledge base's own summary of the criticisms concedes the effect is well documented and non-thermal, while calling its extension to complex experiences speculative. Both halves of that sentence matter. Now to the words themselves, because the labels people use do not all carry equal evidentiary weight. Organized stalking grew a family of names. Gang stalking, community-based harassment, cause stalking. The same thing has happened here. One documented physical effect has acquired a whole vocabulary, and the terms have drifted a long way apart in what they actually assert. Reading the wider literature well means knowing which word is doing which job. Line the terms up and the spread is obvious. Microwave hearing, the Fry effect, thermoelastic expansion, sober technical language from the physics, bioengineering, and physiology literature. Voice to skull, a community umbrella. Synthetic telepathy, a larger claim still. These are not synonyms, though they are often used as if they were. Each sits at a different point on the evidence spectrum, and sliding between them without noticing is how overclaim happens quietly. Microwave hearing and the Fry effect mean something narrow and specific. They name the perception of simple sounds, clicks, buzzes, taps, tonal sensations, produced when pulsed radio frequency energy is converted thermoelastically into a pressure wave that reaches the cochlea through bone. That is all they name. No implication about speech, covert delivery, range, targeting, or operational use. They are descriptive labels for a laboratory phenomenon with a specified mechanism. Nothing more is smuggled in. Voice to skull grew up mainly inside the targeted individual community, and it functions as an umbrella. It covers everything from the narrow digit word demonstration to the far broader claim of continuous covert speech at range. It also covers hearing voices that seem to come from inside the head, comments on one's thoughts, threats through an apparently internal channel. The knowledge base describes a shared vocabulary that lets members label and categorize experiences. That is exactly what the term does. The capaciousness is understandable. The word was coined by people trying to describe experiences that were isolating and routinely dismissed as psychotic symptoms. Language grows around what people are trying to survive. But it is analytically awkward, because it files very different evidentiary situations under one label that implies one well-understood mechanism. Synthetic telepathy stretches the umbrella further still. Thoughts read at a distance, thoughts inserted, and that is part 14 subject. None of this makes the community's vocabulary wrong to exist. It is not required to meet the standards of scientific nomenclature. But precision matters when journalists, researchers, and lawmakers are weighing specific claims. So from here on, this series will say which part of the umbrella it means. And to do that properly, we now go back to the one demonstration under it that is real, and examine it in detail. So we have the vocabulary. Now we go back to the one experiment the whole vocabulary rests on. Earlier we mentioned the words 1 to 10, transmitted by microwave and heard inside a listener's head. That demonstration deserves a closer look because who ran it, how it was done, what was measured, and where it appeared are routinely exaggerated in one direction and dismissed in the other. Getting the detail right is our best defense against both. The experiment traces to research at or in association with the Walter Reed Army Institute of Research in the early 1970s. Several American laboratories were then studying what microwaves do to living tissue, partly because personnel worked around radar and communications gear, partly because of institutional interest in non-lethal effects. The program covered thermal damage thresholds, cataract formation, behavioral disruption, and hearing. Microwave hearing was one line of inquiry among many. The most widely cited published account appears in a 1975 review article by Don Justison, titled Microwaves and Behavior, in American Psychologist, the flagship journal of the American Psychological Association. Justison was a psychologist at the Veterans Administration Hospital in Kansas City and taught at the University of Kansas School of Medicine. His review surveyed what was known about microwave bioeffects, drawing on open literature and military work presented at conferences or summarized in technical reports. Justison's account is concise but specific. Researchers recorded the spoken digit words 1 through 10. They processed each recording to extract its amplitude envelope, the rising and falling loudness contour of the word. That envelope was used to modulate a microwave carrier, a technique called amplitude modulation. The modulated carrier was radiated from an antenna toward a volunteer seated nearby. The listener said what he heard, and his answers were checked against what had been sent. The recognition rate was high. Justison reports that the listener correctly identified the great majority of the words. Some descriptions of the experiment put it as high as 9 out of 10. That is a real result, and it should not be minimized. But notice what is being counted. 10 known words, drawn from a list the listener already knew, identified one at a time in a laboratory by a listener who knew he was being tested. The encoding matters. Amplitude modulation by a speech envelope captures the overall loudness contour of a word. It discards the fine spectral detail, the exact distribution of energy across frequency bands, and that detail is precisely what separates one phoneme from another, and one speaker's voice from another's. An envelope can carry rhythm and stress. On its own, it is a thin channel for the information that makes speech intelligible. Which is why the choice of stimulus is so important. 10 isolated digit words, each a single syllable, each acoustically distinct from the others in its loudness shape, are close to a best case for envelope encoding. Continuous conversational speech is not. It carries rich spectral structure, and identifying its phonemes depends on fine frequency discrimination. Making that intelligible would almost certainly demand a far more sophisticated encoding scheme than the one described here. Range is the second constraint. Justison describes a subject positioned near the antenna in a controlled laboratory setting. No exact distance appears in the published literature, but the power densities described, on the order of milliwatts per square centimeter at the head, are consistent with ranges of about a meter or less, given the transmitter powers a laboratory of that period could put on a bench. Nothing in the record describes reaching across a street. The knowledge base preserves a widely circulated description of the same work. Its wording is worth hearing exactly, because it is the sentence most often quoted secondhand and least often read closely. Note what it says and what it does not. One named researcher, seated in a chamber, recognizing words carried on an audiogram. It is a first-person laboratory report. It is not a description of a device used at range against somebody who does not know. Proportion tells you something too. Justison's review devotes far more space to thermal effects, to exposure safety standards, and to the basic psychophysics of microwave hearing than it does to the speech demonstration. It is presented as one interesting result inside a survey, not as the centerpiece of an argument that a working voice weapon existed. That is how the scientific community of the day read it. Suggestive and a long way from mature. And then the published record stops. No publicly available follow-up study from Walter Reed or from any other institution scaled the demonstration to full sentences, tested it at operational range, or tested it covertly on a subject who did not know. The knowledge base entries on this period say the same. The trail in the open literature goes cold somewhere after the middle of the 1970s, and it has not resumed since. This does not mean the work stopped. Classified research may well have continued behind closed doors. We cannot see it, and we will not pretend to. The biologist Robert Becker, writing about the same period, thought the covert applications were obvious. But an inference about applications is not a demonstration of one. Absence of published capability is not evidence of a hidden capability. Saying otherwise is this whole genre's characteristic failure. So that is the experiment, described as precisely as the sources allow. The harder question is what happened next, how a narrow laboratory finding became, over roughly 3 decades, the foundation of a belief the finding itself does not support. That transformation is worth examining on its own terms, without contempt, because it shows how solid science behaves when it travels away from the specialists who produced it and into general circulation. 3 forces did most of the work. The first is simple astonishment. Learning that a radio wave can become a sound inside your skull feels like watching a law of physics break, and the natural response is to assume the implications must be enormous, that if this much is true, the larger claims traveling beside it must be true as well. Psychologically understandable. Logically, though, it does not follow at all. The second force was the 1998 Pentagon report. Its public release gave the maximal claim an air of official acknowledgement it had not fully earned. To a reader and used to the conventions of government technology assessments, the hedges, the conditionals, the careful line between demonstrated and speculative, the document could read as confirming a working voice weapon, rather than confirming a real phenomenon and one narrow demonstration 2 decades old. Selective quotation did the rest. The third force is the one we keep returning to. The perceived sound leaves no acoustic trace outside the head, so no bystander, no microphone, and no instrument can confirm or refute what a person reports hearing. The knowledge base notes that when the National Academies examined the Havana embassy incidents, they called the microwave auditory effect a plausible explanation, while stating plainly that they could not confirm source, intent, or mechanism. That evidentiary vacuum is an open invitation to overclaim and to dismissal alike, and it is exactly why this chapter has insisted on reading the literature for what it actually says. Before the final chapter assembles the whole picture, one more section on discipline, because this is the terrain where sober analysis most often collapses in one direction or the other. The mature stance holds 2 things at once, without letting either erase the other. Hold the first half. People across different countries, cultures and decades describe in-head buzzing, clicking and voice-like sensations in strikingly similar terms. Some of them had no prior knowledge of the microwave auditory effect, no contact with the targeted individual community, and no obvious gain from reporting. Convergence like that, in any other field, would be treated as preliminary evidence that a shared underlying phenomenon is being described. It deserves explanation, not a shrug. Now hold the second half. The base phenomenon behind at least some of these descriptions is solidly documented physics. Phrase experiments from 1961, published in 1962. The mechanism measured independently by Foster and Finch in 1974. And a real, if narrow, speech demonstration in the 1970s. None of that was invented by the targeted individual community. It came from mainstream, peer-reviewed science, and it was published in credible journals. What is not documented is the largest version of the claim. A device covertly delivering continuous, targeted, naturally intelligible speech to one specific unaware person at meaningful range. Treat the whole umbrella as proven because part of it is, and the subject collapses the moment anyone checks. Treat it all as fantasy because part isn't proven, and you throw away 60 years of legitimate science. Next, we put every piece on the table together. So let us do what that middle position demands, and lay the pieces out on the table where anyone can inspect them. There are only 3 of them: a documented physical phenomenon, a government report that acknowledges that phenomenon, and a line drawn between what those 2 things actually establish and the far larger claim that circulates under the label V2K. 3 pieces, handled honestly, give you one honest picture. Piece A is the microwave auditory effect itself. Alan Fry published it in the Journal of Applied Physiology in 1962. People standing in a pulsed radio frequency field heard buzzing and clicking that seemed to arrive from inside their own heads. In 1974, Foster and Finch, writing in Science, measured the pressure wave and confirmed the mechanism. This is demonstrated science. It is replicated, it is explained, and it is not credibly contested. Be precise about what that effect delivers. The pulse's energy, width, and repetition rate govern what a person perceives, and the pitch tracks the dimensions of the head rather than the carrier frequency. Mid-1970s dosimetry by Cho and Guy put the threshold near 16 millijoules per kilogram absorbed in a single pulse. The knowledge base notes that modern voxel head models now estimate that dose in realistic anatomy. Clicks and buzzes, not conversation. Piece B is the 1998 Department of Defense report, Bioeffects of Selected Non-Lethal Weapons. It did not discover the phenomenon. It acknowledged one already 36 years old. The report names the frequency 2450 MHz, describes thermoelastic expansion as the mechanism, and catalogs what people hear: buzzing, ticking, hissing, knocking. It is a filed planning document. A filing proves that somebody wrote and cleared it, not that a device exists. That sentence gets quoted constantly, so handle it with care. The knowledge base preserves it through J.J. McMurtry's compilation, and its origin matters. It comes from a Defense Intelligence Agency review of Communist bloc scientific literature. That is an analyst summarizing other people's published claims. It is a filing about foreign research, not an experiment the agency ran, and not a demonstration anybody has since reproduced in the open record. Read that report the way a lawyer reads a contract, by its grammar. Documented capability arrives in declarative sentences. The mechanism is this, the frequency is that, the effects are these. Possibility arrives in conditional ones. Could be developed, may become feasible. Institutions write that way deliberately, and the discipline is useful to us. Where the verbs shift into the conditional, the evidence has stopped and the speculation has started. The report also references a single historical demonstration, an early 1970s experiment associated with Walter Reed, in which the words 1 to 10 were transmitted and understood. That is genuine, and it is narrow. A cooperating subject, a laboratory, close range, 10 known words from a closed list. No walls, no distance, no secrecy. It is the highest rung the public record reaches on speech, and it has not climbed higher since. One demonstration. More than 50 years. In all that time, no published replication, no extension to continuous natural speech, no demonstration at range, through a wall, to a person who neither consented nor knew. That absence is real information, and it must be stated carefully. It prevents us from asserting the maximal claim as established fact. It does not, by itself, prove that no classified work exists anywhere. Those are 2 very different statements. Piece C is the line itself, and it is narrower than most people assume. It does not say that covert targeted speech is impossible. It says the public record does not currently support it. The knowledge base entry on the 1976 Senate Subcommittee on Constitutional Rights, for example, mentions intelligible speech in passing. But a claim restated inside a summary is not the same thing as a claim demonstrated inside a laboratory. Here is the vocabulary the published record actually supports. Phrase subjects reported buzzing, clicking, and hissing. The Pentagon report adds ticking and knocking. Later work describes chirps and tonal sensations that shift with the timing of the pulse train. Every one of those is a simple sound event. Nowhere in that list is a sentence, a name, a threat, or a conversation, and that missing entry is this chapter's whole argument. Hold that thought carefully because it cuts in both directions and most people swing it only one way. The empty shelf stops us asserting a covert speech weapon as established fact. It equally stops us asserting that classified programs produced nothing beyond the open literature. We do not know. Saying so is not fence-sitting or evasion. It is the only claim the evidence supports, and the only one that survives cross-examination in a serious room. So what does holding that line actually change for someone living with this? A great deal, and not in the direction people expect. Discipline gets sold as caution, as asking a person to claim less than they experienced. It is not that. It is a way of describing an experience so the description keeps its force in the rooms where being believed has real consequences. Here is how the framework works. Consider two sentences a person might say. The first, I experience in-head sounds consistent with the documented microwave auditory effect. That statement is grounded in citable, peer-reviewed physics, and an informed listener cannot simply wave it away. The second, continuous sentences are being beamed into my head from a satellite. Public evidence does not support that, and when it is dismissed, the documented science standing behind the first sentence usually goes with it. And a person can genuinely perceive an in-head sound without knowing what produced it. The candidate sources are several, and for any individual case the public record usually cannot separate them. That is not an accusation, and it is not a diagnosis. This series does not tell anybody what is or is not happening to them. It is a statement about the limits of what evidence, at present, is able to establish. So separate three things and keep them separate. The experience is real to the person having it. The mechanism is documented in the literature. The specific source, in most individual cases, is unknown and may be unknowable. The National Academy's panel that examined the Havana embassy cases landed in a similar posture. Pulsed radio frequency was a plausible explanation, while source, intent, and mechanism could not be confirmed. Plausible and unconfirmed, stated in the same breath. Any serious discussion of this subject should start here at the floor. 1962, the discovery. The early 1970s, the 10-digit demonstration. 1974, the mechanism confirmed. 1976, a Senate subcommittee noting the research. 1998, the Pentagon report. 2020, the National Academy's panel. 6 entries in 60 years, and every one of them is public. Anybody arguing this subject without engaging those documents is not being skeptical. They are simply uninformed. For researchers, advocates, and journalists, a method follows from all this. Begin with the 1962 paper and the 1974 confirmation. Read official documents for their hedges as closely as for their claims. Watch the open literature year by year for any genuine replication of that speech demonstration. And label your sources honestly. The knowledge base notes that personal incident logs, however diligent, currently carry no recognized evidentiary weight in a court of law. Keep the 3 levels stacked and never let them collapse into one another. At the bottom, demonstrated science. Measured, replicated, mechanistically explained. In the middle, filed and referenced material. planning reports, and one narrow experiment. At the top, claims that testimony carries but that publication does not. Everything in this chapter belongs to exactly one of those layers, and no claim ever rises a level simply by being repeated with more confidence. Why does any of this matter beyond a debating point? Because recognition gets decided in specific rooms. TI-1 Voice's own recognition study, held in the knowledge base, models 3 pillars: law enforcement, legislatures, and the medical and scientific community. Every one of them source checks. A claim grounded in Fry and in a declassified report survives that check. A maximal claim does not, and it takes the credible part down with it. That one sentence, from our own knowledge base at one.witisk.org, holds both halves at once. Well documented and speculative in application. Neither half is a concession to the other. What remains is the question of what would actually move this line, what a real replication would look like, what a fielded device would demand, and what we should watch for next. That is where we go now. So the method holds. The question now is where it leads. The story of microwave hearing is, in one sense, unfinished, as every living scientific story is. What follows is not a tidy ending. It is an honest account of what 6 decades of published work have settled, what they have not, and what may never be settled in public at all, given how much of the relevant research sits behind classification. 3 things are settled. The base phenomenon is real. The thermoelastic mechanism is understood. And the narrow speech demonstration of the early 1970s genuinely happened. One thing is not settled: how far that engineering can be pushed beyond the laboratory boundaries. That single unknown is where nearly every argument about voice-to-skull actually lives, and it deserves to be named precisely rather than papered over with confidence borrowed from the settled part of the record. Some of that uncertainty may be permanent. If the work continued after the mid-1970s, it continued inside classified programs whose public trace is nil. That is a genuine limit on what any documentary can say. But notice the trap. Absence of published capability is not evidence of a hidden one. Silence in the literature is only silence. Treating it as proof of suppression is this whole genre's characteristic failure, and we will not make it. The uncertainty is uncomfortable, so people resolve it cheaply, in one of 2 directions. One says the base phenomenon is real, therefore the maximal claim must be true. The other says the maximal claim has never been publicly demonstrated, therefore the whole subject is nonsense. Each swaps a hard question for a comfortable answer. Each is intellectually dishonest, and each, in its own way, throws away evidence that a careful reader actually has. The honest resolution is less satisfying than either shortcut and far more durable. Say plainly what is known. Say plainly what is not. Then let the boundary itself do the work, because a boundary drawn accurately is a finding in its own right. It tells a court, a committee, or a journalist exactly where to look, and it does not collapse the first time somebody checks a citation against the paper it came from. Naming the bar makes the gap easier to see than to argue about. First, continuous natural sentences, recognized reliably, with accuracy measured and reported in a peer-reviewed journal. Second, a working distance actually tested and stated, because a claim with no range cannot be falsified. Third, independent instrumentation confirming the exposure occurred, since a percept no microphone can capture otherwise rests entirely on one subjective report. None of the 3 is in the public record. The knowledge base preserves a line often quoted as though it closed the question. It comes from a Defense Intelligence Agency review of communist bloc literature, and it repays exact reading. It says sounds, and possibly even words, can be induced. That is an assessment of somebody else's published claims, written in conditional language. A review reporting what foreign papers assert is filed evidence of a filing. It is not a demonstration, and should never be cited as one. This discipline is about to be tested harder. Part 14 follows the same physical foundation one step further, into synthetic telepathy and the brain-machine interface, where the claim moves from hearing a sound to reading thoughts, inserting them or linking two brains directly. The public evidence there is substantially thinner than the evidence for microwave hearing, so the gap between documented neuroscience and reported capability is correspondingly wider. The method, though, does not change. 3 things to carry out of this chapter. The first is that the physics is real. The second is that the one documented speech demonstration was very narrow. The third is the least obvious and the most useful. The line between those two facts is not a caveat attached to the finding. In a subject this easy to inflate and this easy to dismiss, the line is the finding. Take them in order. Takeaway 1. The microwave auditory effect is a genuine, peer-reviewed, independently confirmed physiological phenomenon, published by Alan Fry in the Journal of Applied Physiology in 1962 and confirmed physically by Foster and Finch in Science in 1974. It is not a fringe theory awaiting its first reputable scientist. It was not invented by the targeted individual community to borrow credibility. It has survived 6 decades of scrutiny without ever being credibly refuted. And nothing in the chain requires exotic biology or new physics. A microsecond pulse is absorbed by tissue near the inner ear. The temperature rises by millionths of a degree, but far too quickly to expand gently, so the tissue expands abruptly and launches a real pressure wave. The skull carries that wave to the cochlea, and the hair cells do what hair cells always do: dielectric heating, thermoelastic expansion, bone conduction, ordinary transduction. Here is what that is worth in practice. When somebody reports a click, a buzz, or a tonal sensation that seems to start inside the head and that nobody nearby can hear, a documented physical mechanism exists which could, under the right conditions, account for that experience. That is a statement about physics, not about any individual. It settles no particular case. What it does is give the report a grounded vocabulary instead of a guess. Takeaway 2. The one documented instance of speech through this channel was 10 isolated single-syllable digit words, 1 through 10, recognized well above chance, roughly 70 to 90%, by a consenting volunteer at close range at 2,450 MHz. Justison reported it in American Psychologist in 1975. That is a real and remarkable result, and it deserves to be stated as one, without hedging. It also deserves to be stated exactly. Between that benchtop result and the alleged covert weapon lie 3 engineering gaps. Power. Energy falls off with the square of distance, so 10 meters instead of 1 costs 100-fold, and walls cost more. Precision. At roughly 12 centimeters of wavelength, focusing on one moving head through structures without bathing bystanders is formidable. Complexity. 10 rehearsed syllables are not conversational speech, with its co-articulation, its prosody, and its vocabulary of tens of thousands of words. So the count. Peer-reviewed, publicly available demonstrations of covert, continuous, long-range, naturally intelligible speech delivered to an unaware target number 0. 0 is a defensible number and worth saying aloud. It does not mean zero evidence for microwave hearing, which is thoroughly documented. It is not a verdict on anybody's lived experience. And it is not proof that no classified capability exists. It is where the publicly verifiable evidence stops, counted honestly in both directions. Takeaway 3, and the one most often mistaken. Stating plainly where solid science ends and speculation begins is not a concession to skeptics. It is what keeps the documented science credible, by refusing to let 60 years of legitimate physics be buried under claims that cannot be sourced. The boundary is load-bearing. Remove it and the whole account becomes unusable in exactly the rooms where recognition is decided, which is the point of building it. And the boundary protects 3 different things at once. It protects the science, keeping Fry and Foster citable rather than guilty by association. It protects the conversation, by supplying an evidence-grounded vocabulary that survives a first round of source-checking in a serious forum. And it protects people who report in-head auditory phenomena by distinguishing their account from the maximal claims that are easy to attack and very hard to defend. This is the standing rule at TI One Voice. Where a claim can be grounded in a 1962 physiology paper and a declassified Pentagon report, we say so plainly. Where it cannot yet, we say that plainly too, without sneering at people who report the larger phenomenon and without pretending the gap has been filled. The primary documents sit in the knowledge base at one.witisk.org for anyone who wants to check us. If you take one habit from this chapter, take the sorting. Demonstrated means a named study, a named author, a year, and a measured result. Filed and reported means a document exists. A patent, a procurement line, a planning report. That proves a filing, never a working device. Claimed means testimony and inference, which can be sincere and still is not a measurement. Keep the three apart and the record holds under pressure. That discipline is not caution for its own sake. It is what makes a record usable in a courtroom, a legislative hearing, or a serious journalist's inbox. If this chapter gave you language that is both honest and grounded, carry it forward precisely, rather than rounding it up to the most dramatic version available. What remains is to set the record down in order, source by source, so that anyone can follow it back and check every step. 3 takeaways, then, and now the ledger itself. Before we hand this episode over, let us set out plainly what Part 13 has established, what it has refused to claim, and where the published record simply stops. Nothing in the next few minutes is new evidence. It is an accounting, the same material laid out so that anyone can check it, argue with it, or carry it into a room where it actually matters. The episode began where the science began, with radar technicians in the 1950s who said they could hear the beam. A buzz, a click, a hiss, apparently inside the skull, with nothing at all for a bystander to hear. Most of their colleagues shrugged. Alan Fry did not. He treated the anecdote as a hypothesis and asked the only question that mattered. If these men are right, what physical mechanism could possibly explain it? Set the dates out and the shape of the record is clear. 1961, Frey's first report. 1962, the paper in the Journal of Applied Physiology. 1974, Foster and Finch in Science. 1975, Don Justizen's review in American Psychologist. 1998, the Pentagon's Declassified Bioeffects Report. 2003, Elder and Cho surveying the field. 6 decades of open literature, and not one credible refutation of the basic finding anywhere in it. Frey's design is why the result held. He randomized the trials so no subject knew when the transmitter was live, and he compared real exposures against sham ones. The perceived sound tracked each pulse, and its character shifted predictably with pulse shape and repetition rate. Then came the decisive control. Several profoundly deaf volunteers perceived the pulses too. That ruled out ordinary airborne sound reaching the ear. The energy was arriving by some other route. And the route turned out to be textbook physics. A microwave pulse deposits energy in tissue. The tissue warms by a few millionths of a degree in a few millionths of a second. That sudden expansion launches a pressure wave. The wave crosses the skull by bone conduction, reaches the cochlea, and the cochlea does what it always does. It reports a sound. Every link in that chain is ordinary science. None of it requires new physics. In 1974, Kenneth Foster and Edward Finch removed the human subject from the argument altogether. Working at the Naval Medical Research Institute, they put a hydrophone into a tank of water, close to soft tissue in its acoustic and dielectric properties, pulsed microwaves into it, and measured the pressure transients directly. No perception, no expectation, no report to doubt. Science published it. That is the difference between an interesting correlation and a specified physical mechanism. The single speech result in the open record is narrow and it is real. In the early 1970s, in work associated with the Walter Reed Army Institute of Research, the amplitude envelope of a voice speaking the digits 1 through 10 was used to modulate a microwave carrier at 2,450 MHz. Volunteer listeners, about a meter from the antenna, identified them at roughly 70 to 90%. Remarkable. Also bounded. 1998 brought the Pentagon's declassified report, Bioeffects of Selected Non-Lethal Weapons. Read its grammar carefully. Where it describes what has been shown, it uses flat declaratives. Humans experience microwave hearing. Short pulses can generate a pressure wave. Where it looks forward, it hedges. It seems possible, the report says, that this technology could be developed. That conditional is doing enormous work, and it is routinely quoted as though it were not there. Between that bounded demonstration and the claim of covert speech at range sit 3 engineering gaps. Power. Radio energy obeys the inverse square law, so 10 times the distance costs about 100 times the power. Precision. At 2,450 MHz, the wavelength is roughly 12 centimeters, and hitting one moving head through a wall is formidable. Complexity. Connected speech carries vastly more information than 10 rehearsed syllables. The precision gap deserves a moment on its own. A laboratory antenna faces one seated volunteer at a known distance and a known angle. A street offers nothing of the kind. Any beam wide enough to find a moving head also illuminates the people, walls and surfaces around it, and reflects and scatters off all of them. The published microwave hearing literature contains no analysis of that problem, because it was never trying to solve it. So here is the ledger, side by side. On the left, documented, simple in-head sounds, the thermoelastic mechanism, the deaf subject finding, the named frequency, and one narrow speech demonstration. On the right, and proven in public, continuous natural speech, covert delivery at range, aiming at one person within a crowd, and a fielded operational weapon. Both columns get stated flatly, with no hedging in either direction. That symmetry is the entire discipline of this episode. One number here carries more weight than any other. The count of published, peer-reviewed, publicly available demonstrations of covert, continuous, intelligible speech delivered at meaningful range to a chosen unaware person is 0. 0 is a real number and worth saying out loud. It does not mean zero evidence for microwave hearing. We spent this episode establishing the opposite. It means 0 at the harder claim, which is a completely different sentence. It helps to name the bar rather than argue about it. 3 things would settle the larger question. Full spoken sentences, not isolated digits, recognized at a measured accuracy and published under genuine peer review. A stated working distance, 3 meters or 30 or 300, whatever it actually is, because an unfalsifiable claim is not science. An independent instrumentation confirming the exposure happened, since otherwise the listener is the only witness. Words do a great deal of quiet work here. Microwave hearing and the Fry effect are technical terms for a laboratory phenomenon with a specified mechanism, and they imply nothing about speech, range, covertness, or targeting. Voice-to-skull, or V2K, is, as the knowledge base puts it, an umbrella term, covering everything from that narrow demonstration to the maximal claim. Understandable and analytically costly, because one label spans very different grades of evidence. Now the honest part. We do not know what classified programs have or have not achieved, and this episode neither rules that in nor rules it out. We do not know a measured working range beyond the laboratory bench. We do not know, in almost any individual case, what produced a particular in-head sound. And a gap in the published record is not, by itself, proof that anything is being hidden. That is the line, and holding it is not caution for its own sake. It is what keeps the documented science credible instead of buried under claims it cannot carry. Someone who says their experience is consistent with the documented microwave auditory effect has said something citable. Someone who says a satellite beams sentences into their skull has said something a skeptic dismisses in one move, taking the real physics down with it. Everything in this episode is checkable, and it deserves to be checked. Fry, 1962, in the Journal of Applied Physiology. Foster and Finch, 1974, in Science. Justison, 1975, in American Psychologist. James Lynn's 1978 book. Cho, Guy and Galambos in 1982. Elder and Cho in 2003. And the Pentagon's Bioeffects Report, publicly archived. The full reference list sits in the knowledge base, document 19. If this episode gave you language that is both honest and grounded, use it. TI One Voice lives at 1.witisk.org. A knowledge base, a declaration you can read and sign, and a community that documents carefully rather than loudly. Our live stream, TITV, runs at meet.witisk.org, under public, TITV. Bring your records, bring your questions, and bring your skepticism. All three are genuinely welcome. Next time we follow this same foundation one step further. Part 14, Synthetic Telepathy and the Brain-Machine Interface, moves from sounds to thoughts, and to the alleged reading and insertion of mental content at a distance. The open literature on brain-machine interfaces is genuinely remarkable, and it is also far thinner than that claim requires. We will hold exactly the line we held here, and it will be tested much harder. Thank you for staying with this one. It was harder than it looks because the temptation runs in both directions, either to inflate a real finding or to sneer at people describing something a real mechanism could produce. If you carry one thing forward, carry the boundary precisely, rather than rounding it up to the loudest version available. We will see you in Part 14. This is Knowledge Targeting from TI One Voice.